Hello there, this is Niele from Toolchefs and welcome to this new video. Today we're going to have a look at the new virtual root feature that was introduced in Atom's VFX 5.1, and the purpose of this feature is to add a virtual root to our agents, like you can see here in the preview. So this virtual root is not really a joint, it's just something that we add on top of during the simulation on the skeleton. With previous version of Atoms, basically it was as if this option was off. So you see basically this is the preview that we were getting before. With this on, you enable the virtual root, and here you can provide a position for such virtual root. Of course, for your agent types, this would change, but usually it would be at the same height of the foot tips. Basically, so the question is why we introduced this feature. So with this feature, you're going to have better locomotion, you're going to avoid drifting problems with idle clips, which is something that Atoms has been suffering for a while. Also, you'll be able to place agents directly on the assigned positions assigned by the layout modules without using any other offset or a high field. And of course, if you have like a skeleton with the root already between the feet, then you would be able to use that instead of actually using the virtual root. But anyway, if you have like skeletons like the ones that we are shipping with Atoms or with the Atoms agents, you will be able to have that option, so having like the root between the feet by just enabling this option. To make the virtual root work properly, there are a few settings that you need to change. So the first ones are the ones in the agent type that we already saw. The other ones are in the animation clips. So as soon as you select a compatible agent type that has the enable virtual root option on, you'll find some new parameters appearing. The first one is the virtual root axis, which defines which motion is being transferred from the skeleton root to the virtual root. So in this case, we're just saying transfer the motion on the z-axis. And this is because our clip is moving on the z-axis. For clips like the man idle, which are basically in place clip, we don't need to transfer any motion, simply because the virtual root is going to be static and the motion is going to be preserved on the skeleton. And then for turning clips, we want to transfer both the x and the z, the motion on the x and the z axis. There is another thing that you can do. So for clips that are different, so for instance sitting clips and so on, you might want to change the virtual root position just for that specific clips, and you can do that by changing the override virtual root position and then providing the new value here. Okay, so now let's have a look at how you can use the virtual root in a simulation. Okay, so now let's have a look at the first benefit of having a virtual root. So if I create an agent group, actually before that, let me disable for a second the virtual root on the agent type. I could do grid layout and state machine, and you see that the agent, if I also display the position of the agent, is actually generated, and its skeleton root is applied, is basically placed at the position that is given by the grid layout module, which is 0, 0, 0. So if you wanted to take this agent above the XZ plane, you could use an height field, or you could use the apply pelvis side offset option from the grid layout, but this option only works whenever you have the feet configured properly. Instead, if we enable the virtual root and then go back, we see that now the agent actually pop above the XZ plane. This is because now basically the virtual root is in the location that is assigned by the grid layout. So this is particularly useful, especially if you have stadiums and you don't want to have like a like an eye field, or anyway place the agents and use like tag the feet of your agents. Basically, all of these come for free with the new virtual root. Another improvement that you get with the virtual root is the following. So first, let me show you what was happening with Atoms before. So let me disable it for a second, and let me create an agent group with a grid layout and a state machine, and let me display the position. So at the first frame, this position is the position that is assigned to from the grid layout, and this the position metadata is actually the position of the agent. If we press play, we see that the position metadata is changing, and this is because that metadata is being driven by the skeleton root position. So they match. Okay, so this is fine, but if you're relying on the position metadata for something and you don't want it to be affected by the skeleton root animation, for instance, if you enable the virtual root, now we're playing the idle animation. If now I press play, you see that the position metadata doesn't change. And this is because we're not transferring any of the animation for the idle animation, if you remember from the Atoms UI settings for that animation clip. Let me show you actually again so we don't make any confusion. So here you see we don't transfer any motion for any of the axes. So that basically the position of the agent stays the same while the motion is preserved. Here is an example to understand better why this is important. So here we have an agent group and all these agents here have the virtual root option on. We have agents being scattered on this mesh and then the agents are actually following the same mesh. So if I press play, now the agents, you'll see that the simulation looks okay. They're following the mesh and they will be stopping towards the end. This. If I disable for a second the virtual root, and if I rewind, and now basically we are getting that problem where the position metadata of the agent is actually affected by the motion of the skeleton root. So if I press play, some of the agents you see they are not actually following the mesh, and because some unsync clipped are being played. So to avoid this problem, you could actually change the minimum distance for the follow mesh, which is actually saying if the agent is closer than 10 units to the vertex, that agent shouldn't be affected by the follow mesh. So now the simulation should look better, although I'm pretty sure we'll still have like some issues towards the end, simply because again the position is being affected by the skeleton root motion, and the result is not accurate as if we had the virtual root. So again, like the virtual root is pretty good if you want to use it in conjunction with the locomotion. Now you see that if we press play again, see now the simulation looks much better. And this is all for this video. Thanks for watching.